We're going to talk about quadratic formulas. No, quadratic equations rather. Um, so a quadratic equation is an equation that can be written in this format. Sometimes equations don't come in this format, they come differently. So they may not seem like a quadratic equation immediately. Let me give you an example of such an equation. Let's label this as example 1. Say you have x plus 3 equals 10 over x. That at first sight may not seem like a quadratic equation. In fact, it doesn't seem at all like a quadratic equation. It doesn't have an x squared. It only has x's. But let's work with this equation. Um, First thing to notice is that x cannot be 0. That's something that perhaps we didn't do in the previous courses. Before college algebra, we didn't pay close attention necessarily to the kinds of numbers we can plug in for the equation, for the variable. And in this case, we cannot plug in 0. So let's make a note of that, a short note of that. Note x cannot be 0. Because if it was 0, then we would have to divide by 0, and we can never, ever do that. So once we establish that x cannot be 0, we may multiply by x, and remember, we multiply every part on the left side of the equation, so we have x times x squared, and then 3 times x is 3x. And when we multiply the fraction by x, well, we're dividing by x. If we're going to multiply by x, they undo each other, so we end up with 10. We can subtract 10 from both sides of the equation. So now we have minus 10 equal to 0. And now we have a quadratic equation like this one. But at first sight, it did not seem like a quadratic equation. As long as we are here, we're going to finish solving the equation. Although the example was not about solving the equation, the example was about showing that this equation is a quadratic equation, but it didn't look like a quadratic equation initially. So this is the showing that that is a quadratic equation. Now, we have to be careful because in problems, in tests, and quizzes, and assessments, we have to pay attention to what the question is asking. Is the question asking whether we should solve an equation or not, or what the solutions are? Or is the question asking whether the equation is a quadratic equation? So what to do in a problem heavily depends on what the question is. That is just logical. Um, so again, if we were asking to demonstrate, to show that this is a quadratic equation, we would be finished here. If we were asking to solve the equation, then once we get to this point, then we got to move on forward. So the question or the kind of answer we give depends on the question that is being asked. Yeah. So watch out. So let me write a conclusion this far. Okay, so we can just say, put a bracket here and say, this shows that x plus 3 equals 10 over x is a quadratic equation because it can be written eventually in this form. So that's why we can tell it is a quadratic equation. Isn't that funny? Something that may not look a quadratic equation is actually a quadratic equation. The solutions of a quadratic equation and actually any polynomial equation are called roots or solutions, of course. Now, I want to put emphasis on roots. This name is a little bit misleading. It is misleading. For instance, if we have the equation, so let me write down a number 2x plus 6 equal to 0. You know how to solve this linear equation. So 2x is equal to negative 6, and that means that x equals negative 3. So this guy, negative 3, is a root of 2x plus 6 equals 0 of this equation. Again, that is a little bit misleading because a root, well, a root, of course, means, so we can ask the question, isn't a root this, with something in it? And the answer is yes, that is a root. That's the square root of symbol, okay? But we also use the same name, not to get a root, but to get, a root like this one, but to get a solution of a polynomial, which can be confusing. So watch out. Root can mean this, or root can mean the solution of a polynomial. So negative 3 is a root of 2x plus 6. And that is confusing, I have to admit. But now that we have established that we use the same name for two different things, now we can avoid the confusion. So when we ask to find the root of a quadratic equation or the roots of a quadratic equation, then we know that what we mean to say is that we are finding the solutions of a quadratic equation. So we gotta establish that very clearly before we even start solving quadratic equations. Okay, so what methods do we have to solve a quadratic equation? We have the method of factoring. So factoring method. It is a preferred method because it's very neat, very clean, very straightforward. Let's look at some examples. Well, some easy examples. Let's say you have x minus 3 times x minus 5 equals 0. Okay, so this is already factored. So this problem is a quadratic equation. Why? Because if we FOIL this out, we will end up with an x squared minus 8x plus 15. But we don't want to do that because this is already factored. So if we were to solve this equation, it would be easier to leave it the way it is. Again, please pay close attention to what the question is, because depending on the question, we may go in one direction versus going in a different direction. So for instance, if I was asking you to show that this is a quadratic equation, then we FOIL it out and we write, actually, let's do it. So if we FOIL, then we end up with x squared, outer terms minus 5x, inner terms minus 3x, plus 15 equal to 0. Don't forget this 0, which really is x squared minus 8x plus 15 equals 0. So what did I achieve by doing this? We showed that x minus 3 times x minus 5 is a quadratic quad equation. Oh, I didn't put this 0. Let me put this 0 over here. Otherwise, we don't have an equation. Yeah, I almost missed that. So this with equaling 0 is a quadratic equation. All right. If we were to solve the equation, then we do something else. Then we use what is called the zero product property, which states that if a product is equal to zero, then either this is equal to zero or this is equal to zero, but that's it. There's no other possibility. So x minus 3 is 0 or x minus 5 is 0. All right, and that means that x has to be 3 if we add 3 to both sides of the equation, or x has to be 5. And those are the two solutions of the equation. So in this case, we solved the equation x minus 3 times x minus 5 equal to 0. Right. So what are we going to do with this? Well, it depends. It depends what the problem says. Yeah, and we can probably ask other questions about it. Okay. So one kind of problem that I see students making a mistake on is this one. Let's say you have x squared equals 5x. And they say, well, just divide by x. Okay, so this is not the way to do it. Not how to solve. Okay, they say divide by x. So when we divide x squared by x, we end up with x. Divide 5x by x, we end up with 5. And they say, oh, there we go. Okay, so what is wrong with this is that we're missing one solution. Quadratic equations typically have two solutions. And we only found one. So when you find only one, when you initially start with a quadratic equation, you gotta be careful. You gotta be suspicious. Why do we have only one when a quadratic equation should have two? That should be a red flag. So only one solution for a quadratic equation, quad equation, means something could be could be incorrect. Not necessarily, because there are some quadratic equations that have only one solution. It is labeled as a repeated solution. Anyway, so in this case, what we really want to do is move everything to one side of the equation, because dividing by x implies that x cannot be 0. And so we are rejecting 0 as a solution automatically when we are doing this. But it could be that that 0 is a solution. So there's two ways to attack. Let me show you the standard way, I would say. Move everything to one side of the equation, factor, so factor the x out, so we have x minus 5, and then use the zero product property that says that if two things multiply to 0, then this guy is 0 or this guy is 0. So we have that x equals 0 or x minus 5 is equal to 0. So there's one solution, and of course we got x equals 5 as the second solution. So we have two solutions, 1, 2. Here, in this method, we only have one, and we're missing a solution. So this is one way to go about it. The other way to go about solving this is to test whether 0 is a solution. If 0 is a solution, then record it as a solution, and then for future steps, for further steps, then we can assume that x is not equal to 0 because the x equals 0 solution has already been recorded. So we don't have to worry about that. Yeah. This is probably a little better because if there was a multiple, if 0 was a solution with higher multiplicity than 1, then setting x equal to 0 may not capture that. Um, that's for higher degree polynomials, not quadratic polynomials. Yeah, so it's probably best to just factor and move on. Yeah. Um, Oftentimes the problem doesn't is not factor rather. So let's say you have x squared. Oh, let's look at the example we started out today. Remember, x squared plus 3x minus 10 plus 3x minus 10 equal to 0. Okay, and we want to solve this quadratic equation. Solve this equation. All right. I did not write down in example 4 to solve, but I'm going to put it down now. Solve this quadratic equation. All right. So we can factor. Now, it takes a little bit of skill to factor. I think x plus 5 and x minus 2 is the only way to do it, because 5 minus 2 is 3, and 5 times negative 2 is negative 10. So I think that will do it. If you write down x minus 2 first and x plus 5 second, we're good. Okay, this product is equal to 0, so we may use the 0 product property. Yep. And so we split the equation into two equations. We split it into as many equations as we have, rather as many factors as we have. So x plus 5 equals 0, or x minus 2 is equal to 0. Yep. And so in this case, x equals negative 5. And in this case, x equals 2. And here we have the two solutions. And we are all set. Yep. 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 New example 6. Solve x plus 5 times x minus 2 equaling let's see if this works. 60. Okay. So this is an important example. I see many students making mistakes with this example because they want to transfer the 0 product property when there is no 0. So that is an important thing to note. We cannot transfer the 0 product property when there is no 0. That's why it is called a 0 product property. If you don't have a 0 here, a product and equaling 0, we cannot do anything with it. So some students put x plus 5 equals 60, x minus 2 equals 60. That won't work. Don't even try it. It's messed up. No way. Absolutely not. As soon as we do that, the whole thing is falls apart. It's not even logical to do that. The only time we can use the 0 product property, which allows us to split equations into more than one equation, is if we have a product and if we have 0. Very important. So this is messed up. We cannot do that. All right. So the question still remains, how do we solve this? Okay, so pay close attention to that. Students who don't pay close attention to details tend to perform not as well. And it is not that they're not smart. Of course they're smart. They just miss little things like the 60. Now, in tests, those little things get magnified. We get a lot of points off because that's the point, that we are testing whether students know zero product properties and when to apply them correctly. So yes, they do get magnified, the mistakes. Anyway, so multiply this out. X squared plus 5x minus 2x is 3x. And then minus 10 still equal to 60. So we FOILed from here to here. Then move the 60 over because we want to have 0 on one side of the equation. X squared plus 3x minus 70 equal to 0. And then let's try to factor this back. But it's not going to factor as 5 minus 2, which gives us 3. What I'm thinking is that it's going to factor into 10 minus 7. So x plus 10, x minus 7 equal to 0, because 10 minus 7 gives us the 3. 10 times negative 7 gives us negative 70. Sure, that works. So now we can, okay, but now we got the 0 on this side of the equation, and we have a product, a straight product. So when we have that, then we may split this into two sub-equations. On one hand, x plus 10 is equal to 0. On the other hand, x minus 7 is equal to 0. So x equals negative 10, or x could be equal to 7. Yep. Now, I keep saying or. Remember that or in mathematics means union. Yeah. When we say, so we are saying that this union of those two, as in sets, is the solution set to this equation. Now, it's not a bad idea to plug in at least one number to make sure we're good. If x was equal to 7, as we are claiming down here, then 7 plus 5 is 12. 7 minus 2 is 5, and 12 minus 5 is 60. Oh, we want to double check that. I want to review something. Let me write the equation here. So let's elaborate a little more. We got x plus 5, x minus 2 equals 60. And we claim that those two are the solutions. Why? Because let's test the 7. Test the 7. Okay, so if we put 7 plus 5 and 7 minus 2, that is going to be 12 times 5, which indeed is 60. So we're good. Now, the one thing I want to emphasize is that we have to use 7 for both of the x's. We cannot use 7 here and negative 10 there, or the other way around. We have to have 7 for every one of the x's that shows up in the equation. So when we have one solution that works independently, the other solution also works. So we want to test the negative 10. Okay, let's see. So we have negative 10 plus 5 times negative 10 minus 2. That is going to give us negative 5 times negative 12. So 5 times 12 is 60, and negative times negative is positive. So we still end up with 60. So we're good. Okay. It is a good idea. I strongly recommend, especially if you have the time, to double check your solutions, put them back into the original equation, the very, very original equation, and see if they work. Especially if you're taking a test, an assessment, a quiz, because otherwise we're going to be losing points. And again, it isn't that we're not smart enough to do the problems. Sometimes keeping the points or losing the points depends on whether we're checking our solution. So that is part of what we are testing, whether we can review and check our solutions. Okay. So the method that we just went over was the factoring method. Yeah, factoring method. There's a couple other methods we have to go over. Uh, the square root method. Yep. The square root method. All right. Example 7. Say you have x squared equals 100. Well, just take the square root on both sides. But we we're not we're not using this symbol in the sense that we don't want the principal root. We want all the roots of this equation, every one of the solutions. When we are solving an equation in mathematics and there's nothing else, um, we want every one of the possible solutions, all of them. So we take the square root on both sides and we say, well, there's two possibilities. We could have plus or minus 10. This is the way most people write it. That will be okay. Or we can write x equals 10, comma, x equals negative 10. And this makes it clear that we have two separate, distinct, different solutions. Yeah, so that or this way. So that is simple enough. 8. What if we have x squared plus 100 equal to 0? Well, if we want to use the square root method, then we have to leave the x squared on one side and then move this to the other. So we have x squared equals negative 100. And when we take the square root, there's a problem. We have to use complex numbers. Yeah, because we cannot have a square of a number, a real number, be negative. That does not happen in, yeah, let me write that down. So x cannot be a real number because the square of any real number is not negative. So when we are squaring a real number, we cannot, so this would be a contradiction if x was allowed to be only real numbers. In this case, we're allowing complex numbers. So we take the square root of 100, which is again 10, and we take the square root of negative 1, which is I. So x will be plus or minus 10I, as in the complex number I. So there's two solutions, or x equals 10I, or x equals negative 10I. All right. Sometimes the problem is not as simple. Let's say you have x minus 8 quantity squared equals 100. We would be very tempted to FOIL this out, move the 100 over, and then try to factor that out, which will work. But there's a simpler way. If the equation is already in this format, quantity squared equals a number, then we can use the square root method. Okay, just like this one. Quantity squared equals a number. So in order to apply the square root method, we have to have a single number, a real number on one side of the equation. Okay, like 100. So we take the square root on both sides. Yeah. So x minus 8 equals plus minus 10. And that means that, x, if we add 8 to both sides of the equation, equals 8 plus minus 10. But that's not enough. We may combine those two, so we can just go ahead and do it. And so we can actually write the answer. So x has to be 8 plus 10, which is 18, or x is 8 minus 10, which is negative 2. We will label this as the best way to write the answer, the simplest and best. Yeah. So we're going to call this best if we can combine the two, or simplest, because it is simpler to put down 18 and negative 2, even though those are two numbers, than 8 plus minus 10. Here we have to perform operations in order, or computations in order to figure this out. Yeah. Yeah. 10. And it can get more complicated than that. Let's say we have x minus 8 quantity squared equals 7. Okay. So we have um, square root on both sides. X minus 8 equals plus minus square root of 7. Add the 8, just as we did in the previous example. X equals 8 plus minus the square root of 7. So the two solutions are 8 plus square root of 7, or 8 minus the square root of 7. And that we cannot combine. We have to leave them the way they are. I prefer to write the two solutions independently versus putting them in one equation. I prefer to. All right. So in this case, we cannot combine those two into one number, because this is an irrational number and that is a rational number. And adding an irrational number and then a rational number is not gonna work very well. It's not like adding two fractions. Speaking of fractions, what if we have x minus 8 quantity squared equals 1/4? We take the square root on both sides of the equation, so we have x minus 8 equals plus minus a half. A half is the square root of 1/4, which is interesting because we typically think of a square root as being smaller than the original number. So for instance, what is the square root of 9? 3, and 3 is smaller than 9. However, when the number for which we're taking the square root is smaller than 1, its square root is bigger than the number itself, its principal square root. So this is x equals 8 plus minus a half. But these numbers may combine. It is okay to combine them, and we should. We have to. So x would have to be 8.5, or x would have to be 7.5 when we subtract the 1/2. 8 minus a half is 7.5. So this is the simplest way to write the solutions. We don't want to finish the problem this way. We actually want to perform the computations. Yep. Yep. So that is the square root method. Oh, we have the completing the square method now. Yeah. So we're going to go to example 12. Oh, and I forgot to put a heading to this. I guess I can put it here. Next, we're going to do the completing the square method, which uses the square root method. Yeah. Let's say we have x squared plus 3x minus 10 equal to 0. And we want to solve this equation by completing the square. there's an algorithm, a method, sequence of steps to follow. And I'm going to show you. Well, that was a difficult one, but that's all right. We will stay with it. So the method goes like this. Okay, so we want to rewrite this as a square of something equals a number. So our goal is to have something squared equals a number. So we can do what we did before, the square of something equals a number. That's what we want to do. Now, some of us may be thinking, well, could I just do x squared equals negative 3x plus 10? Can we do that? Because there's this something squared equals a number. The problem is that this is not a number. Not a number. In the sense that we have a variable. So no, we cannot do that to start solving. Some students start doing this, and it sort of makes sense. It's not that this is totally, absolutely nonsense. It does have a little bit of sense, but still it won't lead to the correct way of obtaining the solution because we cannot get rid of this x. So this won't work. Yeah. We have to do something else instead. So the process is as follows. Move the constant, only the constant to the other side. Remember, we want something squared equal to a constant. So move the 10 to the other side of the equation. Add 10 to both sides of the equation. And now we need something that will cause this to factor perfectly, factor into a perfect square perfectly. So what we do is figure out what has to go here to make that work. This is called the linear term. The plus 3 is the linear term. So what we do is take the linear term, divide it by 2, and square it. I'm going to emphasize that we have positive. So take the positive 3, divide it by 2, and square it. When we do that, we end up with 9 over 4, which we have to add here, 9 over 4. So that's kind of a weird number that came out of the blue. Well, not totally out of the blue. We have to figure out how to obtain it, and it's always going to be this case. All right. And then we engineered this number, this 9 over 4, so that this trinomial factors beautifully. So this guy will be x plus 3 over 2 quantity squared. It does that. It is the number before we square. I mean, x plus the number before we squared. And here we have to add those two together. This is really 40 over 4. I'm going to just show on. So this 10 is really 40 over 4. So when we add those two together, we got 40 over 4 plus 9 over 4. That's 49 over 4. And now we can take the square root on both sides of the equation. So now we got to this. Something squared equals a number. Something squared equals a number. No x in here. If we have an x in here, we're doing something wrong. The x has to be only on one side of the equation, not on both sides of the equation. Okay. So x plus 3 over 2 would take the square root. Now, the square root of 49 is 7. The square root of 4 is 2. Since we're taking the square root, we have to take into account plus or minus. And this means that x is equal to opposite of 3 over 2 plus minus 7 over 2. Now, this is not the simplest form because we could combine those numbers, especially since they have the same denominator already. So on one hand, we have, let's do this in 2 steps. X equals negative 3 over 2 plus 7 over 2. Same denominator, so 7 minus 3 is 4. So that is 4 over 2, which is 2. X could be negative 3 over 2 minus 7 over 2. Same denominator, so we end up with negative 10 over 2, which is negative 5. All right, so let's finish up by stating that x could be 2 or x could be negative 5. Is this a long process? Yes, it is. At the same time, it is very insightful. It shows a process. We practice a set of skills that we should be better at, such as completing the square. That is a good skill to have. Figuring out what number has to go here to complete the square. Actually, factor this out to make sure that we did it correctly. And then continue solving the problem by computations. This is a very, very important um, skill to have in mathematics, the completing the square method. Let's do another one. Example 13. Let me just make sure. Yep, example 13. Um, let's say we have x squared minus 7x. Let's put minus 10 equal to 0. And we want to complete the square. Okay, so we want to solve this by completing the square method. Okay, so we want to add the 10. We don't want to add 7x and 10. We just want to add the constant. The x's have to stay on one side of the equation, the numbers on the other side of the equation. We're going to segregate. X squared minus 7x equals 10, adding 10 on both sides of the equation. Now we have to engineer a number here that will cause this polynomial to be a perfect square. So the way we do that is take the coefficient of the x, which is negative 7, divide by 2, and square it. Now, when we square, whether this number was positive or negative, we will end up with a positive number anyway. However, it is good to remember whether this started out as negative or positive for purposes of the factoring. So when we square that, we get 49 over 4. We're going to add 49 over 4 on both sides of the equation. Now, this is a perfect square. It turns out to be x minus 7 over 2 quantity squared. Remember, 10 is the same thing as 40 over 4. And the reason why I'm using a 4 is because I'm looking at this denominator and I want to end up with the same denominator. That is interesting because we end up with 89. 89 over 4. And 89 is not a perfect square. I was anticipating to have a perfect square, but I guess it doesn't have one, which is not necessarily a big deal. All right, take the square root on both sides. So we have x minus 7 over 2 equals plus or minus, don't forget the plus or minus, and then we're going to take the square root of this fraction. Now, 89 is not a perfect square, so we have to stay with 89 under the root. However, 4 is a perfect square. If we take the square root, it is going to be 2. All right. So x is equal to 7 over 2 plus or minus square root of 89 also over 2. Since we have the same common denominator, may just as well consolidate the 2 and write this as 7 plus or minus square root 89 over 2. And we have two solutions. the 7 plus the square root of 89, and the 7 minus the square root of 89. Each one of those divided by 2. We can say that is our final solution. Yeah, practice completing the square method. It is a good thing to practice. It is very, very important, especially if you think you may be taking more math after this college algebra class. 14. Oh, before that, I'm going to introduce the next. So actually, I didn't wanted to do that. I'm just going to flip the page instead of erasing. We want to do the next method, which is the quadratic formula. Everybody should know the quadratic formula. So if ax squared plus bx plus c is equal to 0 and a is not 0, then x is equal to the opposite of b plus or minus the square root of b squared minus 4 times ac over 2a. Let me talk about notation first, because this is important. Notation. All right. Let me simplify this notation and just put negative b plus, negative b plus a over, and I'm just going to put 2a. That's fine. Okay. So this, I just want to say something about the negative sign here. This negative sign should be clear to be affecting only this b. If we put the negative, so this is not the same as putting the negative outside of the fraction. Now, how do I know something is outside of the fraction if it's not above the line? So b plus a over 2a, those two are not the same because this negative is only working on the little b. This negative, because it is sitting outside of the fraction, is affecting the entire fraction. Okay, so those two are not the same, and it is a big deal to write things incorrectly. And that would be, well, if we mean to put this down, that will be incorrect. If we meant to do this, then that will be incorrect. So we got to be very careful on the way we write our equations. Something that some students have done in the past, and I have to mark it wrong, is they put the negative and it's not clear, if it's kind of halfway out and halfway in, which one is it? Well, this negative is what I called ambiguous. And ambiguous in mathematics is incorrect. Yeah, it's an ambiguous notation. Yeah, is the negative inside of the fraction, which means that it's only affecting the b, or is it outside? If it's halfway, half inside and half outside, then we don't know. We cannot declare whether we have this situation or this situation, and it's got to be very clear which one we mean. Yeah. Same thing happens with negatives inside of additions. Some students put down, this is just a second note, negative a plus b, and they think they are doing negative a plus b. Well, what if you have a sequence of additions here? Where does the negative end? So the way this is written, this negative is only affecting the a, not the a and b. If we really want the negative to affect everything, then we have to put a parenthesis. So versus. Yeah. So if you really want to mean this and you wrote this instead, that is incorrect. Yeah. So please pay attention to where the negative is. So I'm going to make a point of making even the line a little longer to make sure that this negative is only affecting the b, not the entire fraction. I have seen students making mistakes like that. Um, yeah, yeah. This negative doesn't mean that this number will always be negative. It will be the opposite of whatever this number is. Um, this, on the contrary, will always be positive. So a couple notes. Negative b means opposite of whatever b is. So that's note number one. Note number two, b squared will always be positive or zero. If b is zero, then there's no need for the quadratic formula. You can simply use the square root method instead. So the reason why we have different methods is because if the equation comes out to be simple enough so that we can factor it or doesn't have a b, then this is more work, in my opinion, than just factoring or moving the c to the other side of the equation and simply taking the square root. In 2 steps, we're done. But if the equation is not easily factorable, if the equation doesn't have nice numbers, then this method is very straightforward. It works right away without too much drama. So example 14, let's say we have 5x squared minus 6x minus 10 equal to 0. There. I just made this up. I don't have an idea of what the solution is. So factoring, well, there's the 5 and the 10. So factoring might take a while if I try to factor. We could try, 2 and 5, rather 1 and 5 will work for this. 2 and 10, rather 2 and 5 will do, but then we would end up with 25. Fairly quickly we realized this is not easy to factor or even factorable with whole numbers. So what we want to do then is either complete the square or use the quadratic formula. Both methods will work no matter what. Maybe we should do both. This is a good example for completing the square and for quadratic formula. So let's complete square first. This is a good problem for completing the square because we haven't done a problem where the coefficient of x squared is not 1. This one is not 1. Yeah, we haven't done that problem, that kind of problem. Boy, that's going to be a tricky problem, but we're up to the challenge. All right, so move the 10 over. 5x squared minus 6x plus blank equals 10. Now, completing the square does not work if we don't have a coefficient other than 1. We have to have a coefficient for x squared that is 1. If we don't have a 1, this will not work, completing the square. So we have to get rid of the 5. We have to divide by 5. We cannot complete the square as is. Alternatively, we could factor the 5 out, but let's just divide by 5. So we have x squared minus 6 over 5 x plus blank equals 2. Whoa, okay. So that added another complication. Now we have a fraction, but that is not too much of a problem. Negative 6 over 5, which we're going to divide by 2. And then after that, we're going to square. Boy, that's okay. Mind that if we have 6/5, and we're going to take half of that, now let's think about that. 6/5, half of that is 3/5. Again, if we got 6 and you take half of that, now we end up with 3. So we have 3/5 negative, but we're going to square. So that is 9/25. So we're going to add 9/25 on both sides of the equation. Mind, the 2 is 50/25. And the reason why I want to do that is because I want to combine those two fractions. So we want to have the same common denominator. All right. We engineer this number so that it will, so this trinomial will factor beautifully. It will factor into x minus not 6/5, but 3/5 because we're dividing by 2. 3/5 squared. And we have 9/25 plus 50, 59/25. All right. Then we take the square root on both sides of the equation. So x minus 3/5 equals plus or minus the square root of 59 over 5. 59 is not a perfect square, so we just leave it alone with the square root. And x is equal to 3/5 plus or minus square root of 59 over 5. Since we have the same denominator, may just as well put them together as a single fraction. There's no point of having 2 5s in this case. So x equals 3 plus or minus the square root of 59, all of that over 5. So there is our solution, our two solutions for this quadratic equation. Let's do 14 again. This time using the quadratic formula. So I'm going to copy this down. 5x squared minus 6x minus 10 equal to 0. This time we're going to use, so we're going to solve by quadratic formula. Now, we have to establish what A, B, and C are. And it's not a bad idea to do that first. So A equals 5, B equals -6, C equals -10. So the signs go with the number, -6, -10. X is the opposite of B. See, that's why I don't like to say minus B, because we have to think of negative B as the opposite of B. Whatever B is, the opposite. So B is -6. Its opposite is +6. Plus or minus the square root of 6 squared. Well, technically -6 squared, but that is always going to be positive. So that is 36 minus 4 times A times C. All of that over 2 times A. Opposite of B plus minus B squared minus 4 times A, C, all over 2A. $36, let's multiply this out. There's 2 negatives, so we're going to end up adding 4 times 10 is, well, 4 times 5 is 20. 20 times 10 is 200. Okay, let me double check that. So 50, multiplying the other way. 5 times 10 is 50 times 4 Yep, 200 over 10. Okay. 6 plus minus square root of 236 over 10. Now, this is the deal. We have to simplify that, the root. Yeah. So, yes, we just have to simplify that. 236, does 4 go into 236? I believe it does. I'm going to do a quick division here to make sure it does. 236 divided by 4. 5 times 4 is 20. So we got 36 divided by 4 is 9. Yep. So 36, and there's nothing left over. So we can rewrite this as 6 plus minus square root of 4 times 59 over 10. See, there's more work to do here. This got a little more complicated because we have to simplify that. We have to. So that is 6 plus minus square root of 4 times square root of 59. This computation was something on the side over 10. And square root of 4 is 2. So this is 6 plus minus 2 square root of 59 over 10. And we need to factor 2 out of those two. So when we factor 2 out of 6, we still have 3 plus or minus square root of 59 over, and then the 10, I'm going to rewrite as 2 times 5, because then we can simplify the 2's, and we end up with 3 plus minus square root of 59 over 5. So x, I'm just going to rewrite this. X is 3 plus or minus square root of 59 over 5. And usually, I shouldn't say usually, many times, applying the quadratic formula is fast. We get to the answer quickly. And we do. I mean, we did get to the answer on the first step. The problem is that the simplifying can be rather long. We need to know how to simplify very well. If we compare that to completing the square, after the fact, it looks like we used fewer steps in a way. Because we did not have to simplify as much. The 59 was already there. We did not have to, the 59 is here, it's hidden. And here it wasn't. So some of us may be thinking, oh, I guess completing the square is not as bad. I mean, it looks bad initially, but then we realize that actually there is something good about it. Some of the simplifying, not every time, but sometimes, many times actually, the simplifying is easier. So make sure to practice both. Something we have to do too is understand the nature of the solutions. Oh, by the way, those two, this number 3 plus minus square root of 59 over 5, that is called, well, those are two numbers. Those are called the roots of the quadratic equation. Even though, see, remember what I told you earlier in today's video. Root can mean two things. It can mean just that, or it can mean this in the context of solving a quadratic equation. So the whole thing is the root, even though there's a root within the root. That is confusing, but it is what it is. And we're not going to change what other people have used already for that. So let's talk about the nature of the roots. Nature of the roots. And by that we mean the nature of solutions. The quadratic formula uses the square root of b squared minus 4ac over 2a. Okay. If this happens to be 0, then there's no plus minus to do. So then we have only one root. In that case, we call it repeated root. Yeah. So if b squared minus 4 times ac equals 0, then there is no two roots, just one. Okay. If b squared minus 4ac is greater than 0, then there are two different roots. All right. And then it gets more sub-categorized after this. So in this case, if this is a perfect square, so under the umbrella of this guy, if b squared minus 4ac is a perfect square, then the roots are rational numbers. Okay, but if b squared minus 4ac is not a perfect square, then the roots are different from one another, irrational numbers. We should understand what is going on. Oh, and there is one more case. This is because it can tell us something about the nature of the roots. This is called the discriminant. So if the discriminant is 0, then there's only one solution, one root. If the discriminant is bigger than 0, there are two roots. But if the discriminant is a perfect square, the two roots happen to be rational numbers. If it's not a perfect square, the discriminant is not a perfect square, then we have two irrational numbers. And there's one more case that I couldn't fit on this page. If b squared minus 4ac is less than 0, then we have conjugate complex solutions. Conjugate complex solutions. Yes. One equation, I'm not going to do this one, but I want to put it there for you guys to do. Solve x squared plus x plus 1 equal to 0. There's going to be two solutions, and the two solutions are going to be complex numbers. I think this is a neat example. So please solve this. This is a good exercise for you to do. And with this, we will stop this video.